Welcome back to my YouTube channel. If you are just joining this community, my name is Bright Edo, a nursing science student from the prestigious University of Benin, and in the course of this video lesson, I'll be solving various practice questions that cut across different topics in chemistry, okay? And this video lesson is specifically made for students preparing to write the JAMB examination and also the post-UTME examination. So let's get into the first practice question, okay? And in this video lesson, I'll be solving these questions step by step so that when you see them in the exam hall, you can be able to solve them without stress. So let's get into the first question, and it says the half-life of a nuclide is giving us 64 hours. Determine the decay constant of the nuclide. It is very easy. Now, in the look of things, this question is from the topic radioactivity. So we have to know the formula to apply because it is a calculation question. So what do? Let's read the question again. They said the half-life of a nuclide. So the first question we ask ourselves, what is the symbol to denote half-life? This word, half-life. Half-life is given with a symbol and it is T-half. This is something we must take note of, okay? The symbol for half-life is T-half. And according to the question, what's the half-life? The half-life is given to be 64 hours. So I will simply come here and write 64 hours. Now, the question now says, determine the decay constant of the nuclide. So next, we need to know what decay constant is. The symbol to denote decay constant. It is simply a lambda. Okay, so this is decay constant. Okay, now, moving further, after we've successfully done this, next thing we'll do is to look for the formula that relates both parameters, half-life and decay constant. I'm about writing it here now. So the formula is simply T-half is equal to 0.693 over decay constant. So this is the formula that relates both parameters, half-life and decay constant. Now, moving further, we then have to take note of what I want to write, what I want to say now, which is, how do we know the unit of half-life? Because half-life basically is the time to which half of a substance disintegrates. Okay, I just said that half-life is the time to which half of a substance disintegrates. What does this mean? It means that half-life has to do with time. So it is related to time units. So half-life can be expressed in seconds, can be expressed in minutes, can be expressed in hours, can be expressed in days, can be expressed in weeks, months, or years. So these are the unit for half-life. Another question is, how do we know the unit for decay constant? It must be noted here that decay constant unit is a function of half-life SI unit. Now, this is what I mean. For instance, we say half-life unit is in seconds. What becomes the unit for decay constant? I will simply write here as per seconds. Or we can just use the symbol, which is seconds raised to the power of -1. So the point here is this: for we to know if we know the unit for half-life, then we know the unit for decay constant because both of them are function of each other. So from the question now, half-life unit was expressed in hours. So what do you think becomes the unit for decay constant? Per hours. Very easy. Okay, per hours. So if half-life was expressed in days, what becomes the unit for decay constant? Per day. Do you get? So it's going to be symbolized as, let me just use the symbol HR for us, raised to the power of -1. You know, this mathematically will get this. Okay, so this is the unit for the decay constant. And now, looking at the question, we'll just eliminate first of all. Can the answer be in per minute? No. So we are working towards option A and option C because the half-life they gave to us in the question was expressed in hours. But the only way our answer can be in per minute is when the question was being specific to solve the half-life, to solve the decay constant in per minute. That is the only way we're going to work towards option B. But in this context, the question was straightforward. They just gave us the half-life, said we should get decay constant. We already know that the decay constant answer must always be expressed in per hours, okay, which is either option A or option C, as the case may be. So let's solve to know which is the correct answer. So next we'll do is to make the decay constant subject, which is lambda, will now be equal to 0.693, okay, times 1 over the t half, which is the half-life. So we then write 0.693 over what's our t half, which is half-life. It is 64 hours. So here it becomes 64 hours. So what becomes our answer, okay, for the decay constant? So let's do that. So 0.693, okay, divided by 64 hours. That is, okay, 0.01083 per hours. Yes. Do you get? That's the answer. And in the look of things, which option corresponds to that answer? It is option A. So the answer to the question is option A, without stress. So you can see how questions like this are being tackled without stress. You have to be careful so that you don't miss, okay, the answer. So let's get into question number 2, which says a gaseous metallic chloride contains 20.22% of M, which is of the metal by mass. The metal here is unknown. Full stop. The formula of the compound is, so they're not asking us what's the formula of the compound. Let's say I'm the one writing this exam and I'm about solving this question. I will not even, take the calculator to solve. I'll just get the answer without stress, because I already know that there is a metal that corresponds to this atomic, atomic mass. Okay, the atomic mass. There is a metal that corresponds to this atomic mass. And what is that metal? It is aluminium. And I already know that aluminium is trivalent. It means that it basically have 3+ charge. It's a metal. And then they said metallic chloride. Metallic chloride. Chloride is chlorine. And halogens, they are negatively charged with a -1 charge. What do I do next? I then exchange my charges in the sense that Al will not bear 1, because 1 will come here and 3 will go here. That's how compounds are formed. So here becomes Cl3. So what we then have AlCl3 without stress, okay? Because 1 is negligible, so we just get this. So then I'll replace my aluminum I'm already sensing to be to the M back. So I'm getting MCl3. So what becomes the answer? Option C. Do you get? That's the answer. But let's solve to be sure. Okay, we have to know various elements and their atomic masses, and this is one for aluminum. So let's solve. They said that a gaseous metallic chloride contains of 20.22% by mass of M. So it means that it's between two elements, M and Cl, which is chloride. So when you just hear chloride, you know that it's chlorine they're talking about. If you hear fluoride, here becomes fluorine. Do you get? So next thing, now you have to know that the atomic mass of chlorine is 35.5. This is something you must take note of. So according to the question, what was the percentage by mass of M? It was 20.22%. Did they give us, okay, did they give us the percentage by mass of chlorine? No. Remember, percentage is over what? 100. So what do we do? Remember that M plus Cl is supposed to give us what? 100%. And what was the percentage of M? Is 20.22% plus Cl, which is unknown now, which we have to get. So we can continue solving our question, because this is just solving empirical formula. Okay, basic empirical formula. So next we say Cl will now be equal to 100% minus 20.22%. So Cl will now be equal to 100, okay, minus 20.22%, that is 79.78%. So the next thing here, we'll simply come here to write 79.78% for chlorine. So the next thing is to divide. You already know the first step. Divide by the atomic mass. What's the atomic mass of N? Okay, 27. What's the atomic mass of chlorine? 35.5. So let's do that. Let's divide. So we simply have 20.22 divided by 27. So then I'm having 0.75. Let's try here. 79.78 divided by 35.5. That is 2.25. Next, divide by the smallest. Which is the smallest? This is the smallest. So here it becomes 0.75. So when these two go, we have 1. When you divide 2.25 divided by 0.75, that is 3. You can see that we've gotten our answer. So then, from this information gotten, we have M1 Cl3, or we can as well just say MCl3 because 1 is negligible. Do you get? So you can see how questions are being solved without stress. So let's get into the next practice question. If you find this video lesson helpful, make sure you hit the subscribe button to this channel and also share these videos with your friends, okay? Your friends preparing to write same exam you are about writing. Okay guys, moving further, let's get into the next practice question, which is question number 3, and it says the amount of energy required to remove an electron from an atom in ground state is, okay, the amount of energy required now to answer this question is very easy. Okay, let's say you don't even know the answer to this question. What will you do? Okay, looking at from option A to option D, which one has energy in it? It is basically option C, but you have to know why the answer is option C, because the answer is actually option C. Now, it must be noted here that ionization energy is the energy required to remove an electron from the valence shell of an atom. Okay, and as you go across the period in the periodic table, it increases. As you go down the group, it decreases. There is a reason to this though. Now, let's quickly work with the periodic table to see what I just said about ionization energy. Okay, this is hydrogen, this is helium, this is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. Okay, this is the first 20 elements of the periodic table. You know, there are about 118 elements in the periodic table. Okay, 118 elements in the periodic. Why the last element to be discovered was organocene. Now, it must be noted here that elements in the periodic table are arranged in the order of increasing or atomic number, in the sense that hydrogen atomic number is 1, helium 2, lithium 3, beryllium 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. This is the first 20 element of the periodic table. Now, I just said that the energy required to remove an electron from the atom, okay, the valence shell of an atom, is simply called ionization energy. Now, and I said that across the period, what happens to the periodic table, and down the group, what happens to the periodic table. So we have to talk about what are the groups and what are the period of the periodic table. All these vertical columns are called groups. Okay, group 1, group 2, like that, they are called groups. Okay, as they are vertical, they are called groups, but as we go horizontal, they are called periods. Okay, so this is period 1, period 2, period 3, period 4. Do you get? There are about like 7 periods. Okay, this is not the complete periodic table. This is just the first 20 elements, the periodic table of the first 20 elements. So now let's take an example from what I just said. This is lithium. Okay, this is lithium with atomic number 3, and also this is beryllium with atomic number 4. Or okay, let me just use element like what do you call it now? Carbon with atomic number 6. Now, I just said that this is across the period. This is down the group. So I picked the elements across the period. We are about explaining ionization energy. Now, let me draw the shell notation for lithium. Okay, lithium is drawn like this. No, the center structure there is called the nucleus, and the first shell should contain 2 electrons, where any other shell to be drawn will contain 8 electrons. So this is, and we are working towards 3. So I said the first shell contains the K shell. Okay, this is the K shell. and we are working towards 3, so 1, 2, 3. So you can see the way it is. This is the L shell. Remember, it's supposed to occupy 8 electrons maximally. So now let's talk about carbon or center structure nucleus. The first shell should contain 2 electrons. We are working towards, this is the L shell now, we're working towards 6. So what number should I write next? 4 electrons. Okay, let's draw 1, 2, 3, 4. Do you get? So it's 4, this for carbon and this for what do you call it now, lithium. So what's the electron? What is the valence electron here? The valence electron for lithium is just 1. Okay, the valence electron, because the electron in the outermost shell is what? 1. While the valence electron of carbon here is what? The valence electron of carbon is 4. 1, 2, 3, 4. You know, we are working towards the valence electron because ionization energy is the energy required to remove electron from the valence shell of an atom. Okay, so what do? Across the period, as we go across the period, what happens to ionization energy? Does it increase or decrease? It increases. Why? Because the energy required to remove this 4 valence electron from carbon and the energy required to remove this 1 valence electron from lithium, which one is higher? This. So as we go across, so you can see that nitrogen will be more than this, like that, like that. As we are going across the period, the ionization energy is supposed to increase. Do you get? So as we go across the period, ionization energy will increase. Okay, because the energy required to remove this is greater than this as we go across the period. So talking about down the group, let's take an example using lithium again. I'm going down the group, lithium and sodium. This sodium now, let's work with sodium. Center this sodium and 1, 2, 3, 4, 5, 6, 7, 8. These are 1, 2, 4, 6, 8, 10, and sodium is 11. So 1. Okay, so we're having 1 valence electron for what do you call it now? 1 valence electron also for sodium. So what happens to down the group for ionization energy? What happens? Now let's understand something very clear. Now you can see that sodium has how many valence electron here? Also 1. But how many shell does it have? 1, the K shell, the L shell, and the M shell. I believe you are following. Okay, there are 3 shells here. 3 shells. Whereby here, how many shells are we having? The shells are just 2. So the point here is this: the energy, because we are working towards, removing this outermost electron from the valence shell. So, and there is a force of attraction that holds the nucleus with the valence shell. There is a force of attraction actually that holds the nucleus with the what? Valence shell. We are working towards down the group now. We are done with across the period. So let's know what happens if it's increasing or also decreasing. Actually, it's decreasing. Okay. Now, what happens here is that as we go down the group, it decreases in the sense that the energy required to remove this is actually like the energy required to remove this and the energy required to remove this electron, which is greater, is this. Why? Because this particular atom has 3 shells, whereby this one has how many shells? 2 shells. So, and the force of attraction will be large. So the energy we will need is supposed to be higher than this because this one has just 3 shells. So as you go farther away from the nucleus, the force of attraction reduces. Do you get? So this is something must actually take note of. Just know that across the period for ionization energy is increased, down the group it decreases. Now, a proton donor is called what? A proton donor is simply called an acid. Very easy in the sense that, let's say this is an acid, HCl. And when we dissociate it, this H plus Cl minus. This is proton. H plus is what? Proton. So as the acid is being dissociated, it donates a proton. You can see the arrow, donating proton. So a proton donor is called an acid. Which of the following is not a mix? Sorry, which of the following is a mixed acid anhydride? What's a mixed acid anhydride? Or what's an acid anhydride? An acid anhydride is a non-metallic oxide. So a non-metal will combine with oxygen to form an acid anhydride. But mix now is that this acid anhydride, when we now take them, mix them or react them with water, they form 2 acids. Which of them? It is actually NO2. Okay, look at the reaction. NO2 reacting with water because acid anhydride reacts with water to form acids. Okay, NO2 reacting with water, we basically have 2 acids. The first one is HNO2 plus the other one HNO3. One is called nitrous and the other is called nitric acid. Okay, this is nitrous and this is nitric. The reaction is not balanced. We'll balance it by putting 2 because we're having 2 nitrogen here. We're having how many nitrogen here? 2. We are having 4 oxygen, 5, 2, 3, 5, and hydrogen 1. Nitrogen 1, 2, and hydrogen 2. So you can see that this is a mixed acid and nitrogen. Actually, when we take CO2 and react it with water, we'll basically get just one acid, which is carbonic acid, and it's a weak acid, H2CO3. Yeah, same applies. We'll get H2SO3. Okay, so that's it. So question 5 is option A. Explains the Haber's process. Haber process is basically a process whereby a hydrogen gas reacts with nitrogen gas in the presence of finely divided ion. Okay, finely divided ion to form ammonia. So in Haber's process, which was the product form? Ammonia. Here becomes 2. So here becomes 3. Yes. So in Haber's process, we basically get what? Ammonia as our product. And ammonia is also called azane. So moving further, the process whereby a heavy nucleus is split into 2 nuclei of nearly equal masses, which, you know, with the release of energy and neutron, is basically called nuclear fission, not fusion. Fusion, you are bringing things together. Fission, you are splitting. Okay, you are splitting to form smaller components. Okay, now 8. The measure of the degree of acidity or alkalinity of a solution is simply called pH. Okay, this is something we must take note of. The basis of this acid is what? It is tribasic. Why is this acid tribasic? It is tribasic because when we dissociate this acid, we're going to get 3H plus, okay, plus the radical PO4 3 minus. Okay, it is actually tribasic. And lastly, who discovered proton? This was done by a man called Lord Ernest Rutherford. Okay, and this was the man that discovered the nucleus of an atom. Okay, but nucleus of a cell, this in biology now, was discovered by a man called Robert Brown. Okay, but nucleus of an atom was discovered by who? Lord Ernest Rutherford. The same applies to proton. Now, if you find this video lesson helpful and you like this video, do well to click the subscribe button to this channel and also share these lessons with your friends. Thanks for watching.